we're now moving on to how does light interact with matter. Recall when a mechanical wave interacts with matter, it can do one of three things. It can be transmitted, it can be absorbed, or reflected. Do these interactions also happen to light waves? With a partner or someone at home, please develop a list of evidence that you would need to support the claim that light waves can be transmitted, absorbed, or reflected, and record that evidence here. So what you can do is you can go back to your old foldable where we have these pictures in that foldable. And so this is just to remind you of what these words mean. So transmission means that it goes through some sort of a surface. So what would be some evidence where you have seen where light is acting like this, where light can go through a surface? What about absorption, where light gets soaked into a surface? What could be an example of light being absorbed into a surface? And finally, reflection. Where have you seen where light can be reflected off of a surface? Take a moment and do that. Next, we're going to be doing a lab called Light and Matter, and you will need these objects: a flashlight, a beaker or glass, a mirror, a note card or any other thick paper cardstock, a thermometer, water, an empty milk jug, and a hole punch. Okay? Please do punch a hole. If you don't have a hole punch, that's fine. Just cut a hole in some sort of hard paper. You want to place that note card over the flashlight to create a beam of light. This is going to be your light ray, and we're going to shine it at different things. So let me show you what I have. So here I have all the supplies on that list. We've got our flashlight. We've got, I did take a card and I've cut a hole in it. And then I'm gonna go ahead and I'm gonna place it on top of my flashlight like this, so that when I have my flashlight on, I've now created a more, a straighter beam of light there. Okay, let me turn that off. And then I've got my milk jug, my glass of water, a thermometer. Now this is a digital one. It probably is not going to work as good as one that you can see moving, which I don't know if anybody even has any of those. We have them at school, but unfortunately I can't go to school. So, and then my mirror over there. Okay, so what we're going to do, and we're going to be recording this evidence in your book. So let me show you your book again. So in your book, on the next page, page 78, we're going to create a data table like this, and we're going to write down our observations. Okay, so we're going to be shining our light on different things. We're going to shine it at the mirror, and you're going to write down your observations. We're going to shine it through a glass of water, through the empty milk jug, and at the end of a thermometer. And this one might be a little bit more difficult. I have to tell you what you should be seeing, because I don't think we're going to be able to see it. So we're going to complete this chart. You can press pause if you like, if you want to copy down this observation data table. And we're going to get going here, and I'm going to show you what you should be seeing if you do not have these objects. All right. So the first thing we're going to do is we're going to take the mirror, and I'm going to take my flashlight here, and I'm going to turn it on, and I'm going to take it and kind of shine it down at the ground. I'm going to shine it at the mirror. Okay. Should see what's happening as we shine it at the mirror. Okay. I can see, oh, look, there's some light down there. What's happening as the light is being shined at the mirror? Okay, what's going on? Okay, put that back there. The next thing we're going to do is we're going to shine the light through the beaker of water. Okay, so I'm going to come over here. I'm going to shine it through the water. Now, I don't know if you can see what's happening here as I shine it through the glass of water. I'm going to try and shine it on the wall behind. Whoa, look at that. Isn't that cool? Shining it through the glass of water. Seeing a different kind of, what should be just like, if I just were shining it straight at the wall, that's what it would look like. But going through the water, what's happening there? Through the water. What's happening to that light? Okay, the next thing we're going to do is we're going to shine it through this empty milk jug. Not really seeing much there against the wall. Does it make it through to the other side? Probably not too much. See, I can see around there, see around there. Not really seeing much of it going through to the other side. Nope. Just kind of hits it and kind of stops there. All right, the last thing we're going to do is, if you have a thermometer, you can turn it on and you would be shining the light right on the end of this thermometer. And see, it's not going to work. But what you should see is the light should be absorbed by the end of the thermometer, and maybe you might see some sort of difference in thermometer temperature. This one, not so much. But if it were one of those thermometers that moves, what do you think will happen when the energy from the light wave goes into the end of this thermometer? What should be happening to the temperature? Think about energy as heat, and what should be happening to the end of the thermometer. Yeah, see, it doesn't say anything. So what you should see is a slight rise in temperature in the form of heat. So the energy from the light of my flashlight should be being absorbed at the end of the thermometer, causing it to be that energy, light energy, to be turned into heat energy, and hopefully you'll see a difference on your thermometer. All right, going back to our book, we have, hopefully you're able to write down your observations, and we're going into our analysis and conclusion questions. Did the evidence you collected support that light can be transmitted? Okay, transmitted means going through. Record your evidence of any light being transmitted or going through a surface. Okay, going up here, we have, what evidence did you collect that supported that light can be absorbed? Big hint, I actually said it during the thermometer. Absorbed, what evidence? And write it down right there. And finally, number 10, what evidence did you collect that would support the light can be reflected? That's a tough one, that light can be reflected, okay? Remember what these words mean: reflection, absorbed, and transmitted. Okay, moving on. Transmission. Different types of matter interact with light in different ways. Air and clear glass transmit light with little or no distortion. A material that allows almost all of the light striking it to pass through and through which objects can be seen clearly is called transparent. Examine the photo on the right. The squirrel is behind the glass. It can be seen clearly because the glass is transparent. In the lab, light and matter, which you just did, the water and the glass beaker were also transparent. Now, these are words that we're going to be adding to our foldable. So I'm going to show you that in just a moment. Let me read this next section about translucent. Materials such as wax paper or frosted glass can also transmit light. It goes through, but you cannot see them through them clearly. A material that allows most of the light that strikes it to pass through, but through which objects appear blurry, is called translucent. Okay, that's right here. This is translucent. In the figure on the right, you cannot clearly see the two people talking behind the frosted glass because the glass is translucent. The milk jug from Light and Matter Lab is also a translucent material. Now let me show you really quick what this looks like in your foldable. Let me grab my foldable here. In your foldable, which we have started right here, we've got a tab already for your light. We already talked about our electromagnetic waves. And then on the next flap, you want to title it right here, Light Interacting with Matter, which is what this section is called. And you're going to open it up, and I actually do have this in the slides that I attached at the very beginning of this week. You want to see that over here, these two have to do with transmission, meaning it's going through. So you want to add transparent and translucent, write the definition and give me the examples that they gave, okay? And on the next page I'm about to read we're going to talk about absorption and the word opaque, and we're going to write the examples there as well. So you want to add these to your foldable. Like I said, this is in the slides that I attached at the beginning of this week's assignments, okay? All right, going back over here on page 80. Page 80, we talk about absorption. Absorption, where some materials absorb most of the light that strikes them, they transmit no light. No light goes through. Therefore, you cannot see objects through them. A material through which light does not pass is called opaque. Opaque. In the figure on the right, there's light that's blocking light blocking curtains, and the wood frame as well. They're both opaque. You cannot see through them. You can only see through the transparent glass window panes. The last word that we're going to talk about is reflection. When you look at a pane of glass, you sometimes see an image of yourself, and you see that light bouncing back at you. It strikes the glass and bounces back to your eye. Recall that bouncing of a wave off of a surface is called reflection. Here we go, down and up, down and up. Reflected light allows an object to be seen. Everything you see is because of reflected light. Most types of matter interact with light in a combination of ways, meaning you won't see just one thing happening. It'll be a combination. For example, a window pane, it transmits, meaning light goes through it, but it also reflects light, meaning it gets bounced back. Some of the light that strikes an opaque object, such as a book, is absorbed and reflected at the same time. And that's how we can see different colors, and we'll get into that later. 3D thinking. A window's function is to allow you to see through into another space. Construct a model of a light ray that enables you to see an object through a window. Now you can either do it like this, and you can be inside the house, or you can be outside the house, but you need to draw me a picture. Make sure you have a source of light, okay? It could be the sun outside, or it could be a lamp inside, but you need to have it bounce off a window pane, and be able to see it, okay? And the last thing that we're gonna do for this video is that we're gonna show how light compares to a mechanical wave interacting with different materials. So we're gonna go back to page 69 in our CER. So I'm gonna turn back here to our CER on page 69. And here we are at D right here. What evidence have you discovered to compare how light and mechanical waves both interact with matter? So both light and mechanical waves interact with matter through blank, blank, and blank. What were those three words we just talked about? The three vocabulary terms that we reviewed from mechanical waves that light also can act like, okay? So go ahead and fill in letter D, and we'll see you tomorrow.